Okay, we're going to go over comparing rates of change today for Algebra 1. This should mostly be review, so we're going to buzz through things pretty quickly. We did some of this, we reviewed this a little bit in our pre-algebra lesson at the beginning of the year. So here we go, just reviewing rate of change. Remember that is just describes a relationship between two changing quantities. So between two changing quantities. We'll be able to set that up as a ratio between, remember what we call the dependent and the independent variables. Remember, we will apply later the rate of change to the slope of a line and that constant rate of change, but before we do that, we need to understand that rate of change can also be varying throughout the course of certain variables and quantities. So we need to remember that this rate of change is that change in the dependent variable over the change in the independent variable. And typically we will, as we get to slope, we'll list that as it appears as a fraction, right? We won't turn that into a decimal. So let's review rate of change here real quick through an example. This example is going to deal with teen texting. So you can tell by the table right here, our year starts in 2007 through 2010, and it tells us the average number of text messages per month by teenagers. So as you can tell, in 2007, went from 435 all the way up to over 3,000 in 2010. Okay, so we're back here. This example, we're going to talk about the rate of change and how it can be calculated between each interval. Okay, because as we said up above, interval in this table, as we said up above, this rate of change doesn't always have to be constant. So let's find the rate of change from 07 to 08. So first, we know that it's our change in dependent over our change in independent. Recall from our review that typically our independent variable is going to be our time. So when we're finding the rate of change from 07 to 08, we're talking about right there, right? So a lot of times we'll use you'll see me use a shortcut, a triangle, to describe a change in. So a change in our dependent variable over a change in our independent variable. Well, our dependent variable in this case, our number of text messages depends on what year we're talking about. So that's what makes it the dependent variable. So we're talking about a change in a number of text messages over a change in year, right? So we're going here. So the change in text messages, in order to get that change, I'm going to take the later value, 1742, and I'm going to subtract 435. And for the years, I'm going to take the later year, 2008, and subtract 2007. So we know that's going to be over 1, and it's just a matter of finding what we have in the numerator, and that ends up being 1307. So what this is telling us is our rate of change is 1,307 texts per per month. Now that's not how many messages they send. That's our change. So in '07 it was way down here. In '08 it jumped up all the way up here. Okay, so when we're stating that, like in an example, when it says give or explain your reasoning or justify, you'll justify it with all this, and then when you go to explain it, you'll say from 2007 to 2008, the average number of text messages, the average number of texts sent per month. What did it do? Well, it increased by 1,307 text messages. Okay? So why don't you guys hit pause real quick and go ahead and find the rate of change from '08 to '09 and from '09 to 2010. I'll let you do that on your own. Okay, so from '08 to '09, in red here, you should have found that that was going to be 1,157 was our change. And from, let's go green here, from '09 to '10, our change was 440. Okay, so we saw a very large jump, another large jump, and then our jump was much smaller than before. Alright. Now, comparing these intervals and what we're looking at with these tables. When comparing the rates of change to determine which has the greatest or least, the greatest or the least rates of change, you want to make sure that you are comparing the absolute value of the rate of change. Whoops. Absolute value. I'm going to change back to blue here. It's a little easier to see, I think. So what this means is we aren't concerned whether this rate of change is decreasing or increasing, or whether it's negative or positive. Our concern is how severe this rate of change is. If we were to graph it, like we're going to down here, how severe is the slope? How sharply does it go up, move upward? How sharply does it move downward? Okay, for example, if we had two different intervals where the rate of change was negative 3.8 degrees, so let's say the temperature decreased 3.8 degrees, an average temperature from month to month, meaning a decrease of 3.8. And another rate of change was 2.3, meaning an increase. Despite the fact that this number is greater than negative 3.8, I'm worried about the rate of change. So the greatest rate of change here is going to be the negative 3.8 degrees because it is the most severe, even though it is decreasing. Not worried about positives and negatives in this case. I'm worried about the severity of the change. Okay, and here we will illustrate it on the graph. So comparing these on a graph, we're going to find the rate of change for each interval on the graph, then indicate the greatest and least rate of change. Now, to indicate the greatest and least rate of change, we really don't even have to find the rate of change here for each one. We can simply look at the graph, can't we? Each one of these is, the x value is changing by 1. This went from 1 to 2, from 2 to 3, 3 to 4, 4 to 5. Okay, as we move horizontally, each one is changing by 1. However, our y values are changing by a lot more than that. which one would you say here is most severe? Which color line would you say is the most severe change? Well, hopefully you notice that from 5 to 6 is the most severe change, okay? So from 5 to 6 is the greatest rate of change. And you should notice that from 2 to 3 there is no change, is there? So that would be the least. So 2 to 3 would be the least rate of change. Okay. So what we could go do now is, as we know, we could kind of figure out the slope between each point, right? This went up 1 and over 1. Okay, so this black line right here, its rate of change would be 1 over 1. That black line, it's 1 over 1, which we know is 1. It went up. The red one it went up 0 and over 1 for a rate of change or slope of 0. So we're just relating this rate of change to slope here. The green went up from 6 to 10, so it was 4 over 1. And I'm just writing these lines out here so you can see the colors. You can't see them on your sheet because it's black and white, but you can see them here on the screen. So that rate of change was 4. The blue one went up by 2. So the blue one was 2 over 1 for 2. Now the orange one, which we chose as being the greatest or most severe rate of change, actually went down from 12 all the way down to 5, right? So negative 7 over 1 for a rate of change of negative 7. And then the pink one, thinking there, the pink one went down 2 more. So negative 2 over 1 for negative 2. So our move from 0.5 to 0.6, we went down 7. That was our greatest rate of change. Our lateral move here, where we did not increase nor decrease, was our least rate of change. Okay, and now we're going to, on our last slide, we're going to compare our rates of change using the constant rate of change, or applying this to our lines, which we should have a pretty good handle on already. The graph of a line, let's go to blue here again, always has a constant rate of change. And what that means is our ordered pairs, or our points on the line, our ordered pairs, always line up, right? For a line, all of our ordered pairs are right together. So I can draw a line through all of the ordered pairs, all of the x and y values that fall on that line. Our constant rate of change can be found by counting what? What over what? What do you remember? Hopefully you remember. It is rise over run. Okay. So that is our calculation of slope, right? Rise over run. When we have something like this, a graph of a line, typically the easiest way to find the slope is simply to count, if you remember. So let's review, let's try to find the slope. Well, our slope is our rise over our run, right? And let's go ahead and count it, okay? Let's go calculate the rise first, and let's look at this here. So go right there, if we calculate the rise, well, our rise moving from this point to the bottom point, we have to go down, right? Okay. And we went down how many? We went down from, let's see, this was, where is this point? 1, 2, it's a -3, +4. So at -3, +4, and this point over here is at 1, 2, 3, 3, -1, right? So I went down 5 units, so my rise is a -5. So I'm going to calculate the rise first, right? Rise is -5. And that goes over my run, right? So now I will go from this point over to that point. And how far did I run? I ran that way. 1, 2, 3, 4, 5. Looks to be 6 units. Therefore, our slope of that line is a -5/6. And as we know, if I have a negative in any part, any one part of a fraction, it makes the whole fraction negative. So whatever you're most comfortable with, if you want to leave that negative with the 5, or if you like to put it out in front of the whole fraction, it's perfectly fine. Okay, just some key points here. Remember that when you count up or right, it is a what type of value? Hopefully you can fill that in yourself. It is a positive value, right? Positive. When you count down or left, it is a negative value. And we saw that when we counted down, it was a -5. When we counted to the right, it was a +6. And then, as I've told you before, you always want to double check your graph and check if it is positive or negative, and if that is correct. So here we came up with a -5/6. Well, as I read this graph from left to right, is it going up or down? Okay, read graph from left to right. Go check this one. As I read it from left to right, it is in fact going down, so my negative slope should be correct there. Okay. Now, on the comparing tables and graphs, I want you to just follow along with me. We're going to go to the SAS curriculum video. You don't have to go there. I'm going to go there here on the video, so you can watch it with me. Okay. So now we're going to look at comparing tables and graphs. And you've got the back side of your note packet to take any notes that you want to on this. But it should all be review. We're just talking about comparing the things we just talked about.
We can determine whether the table or the graph shows the greater rate of change by finding the rate of change for each of them. To find the rate of change of the table, first find the change in the y values. Then find the change in the x values. Since the change in the y values is +1 and the change in the x values is +3, the rate of change is 1/3.
Remember, our slope, or our rate of change, is change in y over change in x. Rise over run.
Now let's find the rate of change of the graph. Remember, the rate of change is the same as the slope. From the point -1, 0 to the point 2, 2, we rise 2 units and run 3 units. So the rate of change is 2/3. Since 2/3 is greater than 1/3, The graph has the greater rate of change.
Okay, so that was relatively simple comparison there. Uh, let's look at these real quick. Which has a greater rate of change, a line with a slope of 2 or a line with a slope of 5? Well, that one's pretty obvious. The greater rate of change or more severe slope would be the slope of 5. Now, something here, which has a, whoops, this is the same, which has a smaller rate of change. So again, remember, we don't technically have to find the exact rate of change, even though we could find the slope pretty easily by counting here. But we can pretty much just look at these, right? Which one has a more severe slope? Well, this one is pretty obvious that it is more severe than this, so the smaller rate of change would be here. Okay? So you can kind of look at these visually as well. Which has a smaller rate of change? Well, this has a severity of 2, and remember we talked about looking at the absolute value of these rates of change. So this has a severity of 6. The smaller rate of change would be the 2. Okay? And this one would be like the examples, like the example they just worked in the video. So, thanks for following along today. We'll wrap things up now, and I will see you next time in class. Don't forget to go ahead and do the practice problems for lesson 3.1 because you should be able to manage those on your own. Bye-bye.